Hey guys, this is badge 4. Okay, so you might be thinking, well, how am I going to tell the difference? So this is part of what we practice. It's asking, is there convincing evidence that more than half of all adults would consider this food risky? Now, I'm actually going to modify this question because the way this question is written would technically be badge 3, okay? But we know that this is a test because it's not asking us to create an interval. Okay, so I'm going to actually modify this question slightly, which is what I did back in for period 4. All right, I'm going to say, is there evidence that Europe thinks it's riskier? Notice the difference between badge 1 and 2 and 3 and 4 is 3 and 4 give us data from 2 sets of groups. Here we're getting data from Americans and Europeans. What also sets badge 1, 2, 3, and 4 apart is that we're asking yes or no questions. All right, so let's dig in. It says Europeans have been more skeptical than Americans about the genetic and engineering. So we've talked about this in class, the GMOs, right? A sample survey gathered responses from a random sample of that many Americans and this many Europeans. So we're going to call Americans N1, and we're going to call Europeans group 2, right? The European sample was larger because Europe is divided into several nations. So it's okay if the two groups are different sizes, we just need them big enough, right? Subjects were asked to consider using modern biotechnology in the production of foods, for example, to make them higher in protein, keep them longer, or change in taste. They were asked, do they consider it risky for society? So this is a yes or no. In all, 52% of Americans said yes, and 64% said yes, okay? So what was our sample proportion? Again, it looked like we'd actually, for the first time, this is to figure out how many said yes in group 1, we'll take N1 times P1 hat. So what is 52% of 863? It looks like 449 said yes in the first group, because 449 out of 863 would be the sample proportion, 52%. All right, now let's figure out how many said yes in the second group. In my second group, they said 64% said yes, so just kind of working backwards. If we talk to 12,178 people, how many is 64% of that group? And we get a number, 7,794. Okay, so that is our second proportion, 7,794 out of a total of 12178. Now these numbers will be important because these are the numbers we need to put in our calculator, right? Now, let's set up the problem. What is special about badge 4? Well, like I said, we're answering a yes or no question, but we're also not being asked to do an interval. This means that in our state, we have a claim and we have an alternate claim. If we have two populations, we are asked to see if the two proportions are equal, assume they're equal, and then we have reason to believe that, based on the claim, that the second population proportion is higher. All right, so because we used these letters, we have to tell the reader what P1 stands for. It is the true proportion of Americans who think GMOs are too risky, right? Right? And the second proportion is the same thing, but in my other population. So the true proportion of Europeans who think GMOs are too risky. All right, now for our plan. So we go to our plan. R. It doesn't say in the problem, but obviously to proceed, we have to say both samples were taken randomly. So you can say it's assumed both samples were taken randomly. All right. So what for normality? This is, we're back to yeses and nos. So that means we are departing from the central limit theorem and we're looking for 10 yeses and nos, but we need to look for 10 yeses and nos from each group, right? It's also important to note that, just like we did in the yawning sample, if we're going to assume that the opinion is the same throughout both groups, we have to combine these proportions. So I'm going to take a minute to combine these proportions. Does this make sense? And to just grab these numbers, right? That's how many said yes in the first group. That's how many said yes in the second. So 449. In that activity of the yawning, we shuffled our piles of yes, you yawned, or yes, you got the yawn seed, no, you didn't, and shuffled the piles, yes or no, you did yawn. All right, in the same way, sorry, sorry about that.
No problem.
In the same way, I'm going to collect how many people we talked to total, right? So if we shuffle these cards together, right, it looks like we talked to a total of 13,041. And out of those people, this is how many people said yes. All right. That means that 63%. Now, this makes sense because we had more people from Europe, but we were looking for a number between 52 and 64. All right. Nice. So, again, we've got tons of yeses and nos, but we could say 449 is greater than 10. And that's how many yeses you got in the first population. 707.94 is greater than 10, right? And if we subtract that, how many would say no? That would be 863 minus 449. Obviously, these numbers are 4, 1, 4. That's how many no's. These are my yeses. These are my no's. In this group, right? Obviously, these numbers are greater than 10. We talked to lots of people, so we're good. Okay, we could also think how many, if we compile these, how many said yes? So 8243, that's greater than 10, right? And 1 minus that, 1 minus my total group, 4798 is greater than or equal to 10. So we covered our bases here, guys. All right. Independence. This is like it was in our badges 1 through 8. We have independence because our population of USA is greater than 10 in. What was in? 863, so we add a 0. And our population of Europe is greater than 10 in, so 12178. And we add a 0. Okay. Nice. So we have our state plan. Let's do our do. We have our general formula. And we're going to get a z. And then from that z, we're going to get a p. And then from that p, we're going to make our conclusion. So what do we actually get? Well, we did get a difference of proportion, right? So we have p1 hat minus p2 hat, right? And then what do we predict? Well, we have to predict that the groups are the same. So if we subtract 2 of the numbers that are the same, we'd get 0. So if they are the same, we would get 0. And what is the statistic of the two numbers? Now, here's the part that we worked hard to make sure we clarified. we want to write the standard deviation, but of the combined. Assuming, since we have an H sub O that we're supposed to assume they are the same, we'll combine the groups, okay? So the little c stands for the p hat combined. All right. Now for the moment of glory, right? We're going to type this in our calculator. So let's turn this on. Let's get my screen so you guys can see my calculator. I'm just looking for my photos here. All right, here we go. Of course, the calculator I have is just barely plugged in here. All right, so we go to calculate. Menu, stat. We're doing a stat test. They did not ask us to do an interval. We actually have two proportions, right? So how many said yes in the first group? Looks like our Americans, 449 said yes. 449 said yes, and we talked to a total of 863. All right. Then in the second group, 7794 Europeans said yes, out of a total of 12178. 12178. All right, now we have reason to believe that the Europeans like this more, so we're picking that greater than sign. All right, so as we say yes, of course it says an error, so I must have typed this not on an empty space, so that's okay. This will be a good review to do this the second time. We go to stat test, and we're going to do a two proportion. We have two proportions, one from Europe, one from America, right? 449 out of 863, and 7794 out of 12178. 12178. We have reason to believe that the second population is greater. All right, so lots of good stuff here. Yep, I got my Z-score. We're just going to take a nice quick picture of this.